Welcome. This four-part series is a walkthrough of the U2V methodology with focus on building optimized U2V control objects. This is part 2, and the topic is the control object, which is a UnityPro DFB. Along the way, I will present some tips and tricks that should prove useful whether you use the U2V tools or not. Here for review are the U2V development guidelines. All three of these will be addressed in this part of the series. Remember, the fundamental core of U2V is UnityPro and a user or system-specific library of objects. And in UnityPro, this library is DFBs. There's a lot to cover, so I will get right into it. Building U2V DFBs that are optimized is too broad a statement. Optimized for what? That is the question. From a U2V perspective, the general answer is optimized for ease of use. And ease of use can only be achieved if it includes the U2V golden rule. Using the objects shall require minimal keyboard input, or don't make me touch the keyboard unless it's absolutely necessary. So, the constraints on ease of use will be different with nearly every system. Here are a few examples of systems that will require differing approaches to optimize the ease of use. If the system is greenfield or will include at least both SCADA and control, then a pure Schneider Electric plant structure or EcoStructure architecture is preferred, and the recommended Vijeo drivers are OFS OPC for local Modicon Unity controllers and DMPR for DMP3 remote RTU sites using either Modicon M340 with BMX NOR module or SCADAPAC E-Series controllers. Integrating into existing systems can have a variety of challenges related to the available protocols. There could be the constraint of only Modbus Serial or Modbus Plus. There could be local HMI requirements that allow use of the data dictionary, but SCADA still does not. And then there could be something in between. For RTU applications, there could also be the possibility of multiple protocols. This is one of the most challenging. Each of these scenarios will require a different approach to optimize the DFBs for ease of use. Here are some fundamental Unity data basics that must be understood in order to keep up with where this is going. SCADA native Modbus drivers can only access addressed data. Unity is a tag-based system, so in systems using these types of drivers, all data must be located. In Unity, variables can be located or unlocated. There are only three reasons to locate a variable in Unity. First, variables are located, assigned addresses, because they are bound to hardware I/O points, or variables are located, assigned addresses, because they must be accessed by SCADA via native Modbus drivers, like Modbus, Modbus TCP, or Modbus Plus, or because the data must be retentive. Retentive data is data that is maintained through a power cycle of the CPU. Locating variables requires the user to keep track of used and available addresses. Now some Unity DFB basics that must be also understood. DFBs can have 32 input and 32 output pins. These can be of any Unity data type. DFBs also have public variables that have read-write capability but cannot be located. The U2V methodology recommends that DFBs are created for each device in a project, like level transmitters, flow transmitters, motor controllers, etc. It is highly recommended to standardize on a DFB naming convention and make it one that can be easily understood with visual triggering. On the DFB, variables are assigned to the input and output pins and located as required. Also note that DFB output pin data can be accessed by DFB instance name dot notation within your application. This eliminates unneeded variables. DFB input-output pins allow data structures and arrays to be processed with read and write functionality. Data structures are created as a user DDT, aka derived data type. Here is an example of a DDT. Note the spare variable included to assure hardware platform independence. The spare rounds out the DDT address requirements to an even number of words. This is necessary because of the freedom in Quantum to locate 32-bit data on any address. If the spare was not included, the DDT would require an odd number of addresses. This would be in conflict with the constraint in Unity Momentum, M340, and M580 CPUs of 32-bit data only being allowed on even addresses. It is also recommended to group elements of a DDT with like data types adjacent and consecutive in decreasing byte size order. This also helps to ensure hardware platform independence. Padding the DDT with the spare will allow the same DFB created for use in a Quantum to be used in a Momentum, M340, and M580 system without having to sacrifice state RAM addresses. The U2V methodology utilizes public variables extensively. One use is parameters and configuration of the control object. These need to be set but will rarely be changed, and then generally only by someone with engineering level access. With the basics out of the way, here is an example of optimizing a DFB that will be used in a system with a native modbus driver. First, the unoptimized approach. The user creates the DFB with input and output pins that meet the requirements of the control specification. Next, variables are created and attached to the DFB. Then, each and every one of these variables are located according to the need, either SCADA comms or retentive data. Now, the optimized approach. Use a DDT for the SCADA communicated and/or retentive data. Not only does the DFB interface get cleaned up, but now there are only 2 variables to be located instead of 17. And all elements of the DDT are automatically located and accessible by the native modbus driver. At this point, I need to define a term that will be used going forward. I call this DDT the SCADA Data Object Retentive, and you will see this in other examples to come with a variable suffix of either _DO or _DOR. This example has only highlighted one of the many techniques that the U2V methodology teaches to optimize the ease of use of the DFB. If this application required 23 level transmitters, it should be apparent that the simple change made will result in significant time savings. And it must be stated, the unoptimized approach broke the U2V golden rule big time. To create 23 instances, hands would have been all over the keyboard to create the 391 variables required. This example was specific for how to optimize for ease of use a DFB in a project using a non-Schneider Electric SCADA system with native modbus drivers, so there is no optimization related to the SCADA databases or graphic objects. An example for Vijeo SciTech is coming. But first, some more background. In part 1, I explained how the U2V DFB Manager exploits the Unity Pro Program Section Import feature to minimize keyboard usage. So if we combine the DDT SCADA Data Object approach, just described, with the use of the DFB Manager to minimize the typing, we're getting close to a fully optimized level transmitter DFB. The DFB Manager can ease the use of DFBs in many ways. For example, in order for a DFB to be easy to use, first you have to be able to find the DFB that you want to use. This is why the DFB Manager came to exist. I have worked with Unity Pro from day one and been involved with many customers in different market segments. So I have developed and accumulated hundreds of DFBs. Most of these reside in a Unity project somewhere on a hard drive, and I can find the one I'm looking for, but it takes some time. The game of hide and seek finally became unacceptable, and I decided there had to be a better way. The DFB Manager solves this problem by utilizing a simple folder-based organizational structure and a simple set of rules for use. Out of this simplicity comes some other very useful benefits, like a simple, consistent way of using the inherent DFB version management features of Unity. Having an easily accessible single source file for a DFB enables this benefit. Another must-have for a DFB to achieve ease of use: help files. Creating help files and putting them into place can be cumbersome, boring, challenging, and without a defined format, they can become inconsistent. The DFB Manager also solves this issue by auto-generating customizable DFB help files and also automates the installation. Now I will get on with an example of an optimized U2V control object for use in a plant structure architecture. These are built for use with the OFS OPC and DMPR drivers in Vijeo Cytec, and I will first analyze one from an OFS OPC perspective. OFS allows access to unlocated data in a Unity controller, and the data dictionary of the Unity controller ensures that this access is uninterrupted through Unity Pro edits and builds. This is key because it greatly contributes to supporting the U2V golden rule. If I don't need to locate data to access it from SCADA, then I won't, and that keeps my hands off the keyboard. Here is a basic comparison of the level transmitter DFB used for modbus versus the one to be used with OFS OPC. Keep in mind that the code inside of these DFBs will be exactly the same to meet the requirements of the control specification. The only visible difference is the presence of the variables attached to the output pins. What do I hear you saying? Pin variables are not a part of a DFB? You're correct. However, I will play the golden rule card here. Don't make me touch the keyboard unless it's absolutely necessary. And referring back to part 1 of this series, importing Unity Pro project sections automatically creates variables, and the DFB Manager generates importable U2V DFB template section instances. So I will use the Manager to minimize keyboard usage and therefore optimize this DFB for ease of use. Now that the inclusion of these variables is a non-issue, why are they included or necessary? The ability to apply Unity Pro variable custom field content is only unrestricted with elementary data type variables, and these variables will have the U2V syntax VJA and VJT applied to them to identify them as alarm and trend tags in Vijeo Cytec, which in the grander scheme will further optimize this DFB into the total solution. More on the U2V syntax to come. Now back to the comparison. Another difference between the Modbus version and the OFS OPC version can be found in the SCADA data object. The output pin variables of the OFS OPC version will provide duplicate data to elements contained in the SCADA data object of the Modbus version. So these elements should be deleted from the DDT for the OFS OPC version of the DFB. I also want to point out that for this OFS OPC version of the DFB and its DDT variables specifically will require locating, assigned an address, because the data contained in it must be retentive. Set points and other similar dynamic, adjustable, or calculated cumulative data like flow totalization or motor runtimes always fall into the retentive data category. One could argue that it is better to leave these DDT elements and the supporting DFB code in place and only manage one version of the DFB. But allow me to address other aspects of the overall solution that could be optimized. Communications bandwidth requirements, PLC memory usage, PLC scan time. These all have costs associated with them. Eliminating irrelevant or duplicate data and useless code is best. So rather than worry about managing multiple versions of very similar DFBs, consider this alternative. The DFB Manager makes it easy. Simply create a DFB library for each of the protocol situations. Boom, done. Okay, so back to the comparison. There are also other small but important differences related to the OFS OPC version being optimized for use in a plant structure architecture. The differences are in the defined public variables. The Modbus version only contains those related to the requirements of the control specification, and these allow the DFB instance to be configured to match the level transmitter field device and the hardware used. The OFS OPC version contains the same plus several additional U2V parameters that are used by the DFB manager to further optimize this DFB for ease of use. More to come on the U2V parameters later. Now, an example of an optimized U2V control object for use in a plant structure architecture using radios to communicate to remote RTUs. In this example, the Vijeo DMPR driver is used to communicate via DMP3 protocol to Modicon M340 RTUs with BMX NOR module. The DMP3 protocol is a very effective protocol for RTU applications, with inherent features to minimize bandwidth requirements. Systems optimizing these features can expect dramatic system throughput increases over traditional polling protocols. The report by exception and event buffering features enable real-time alarm transmission and trend backfill as a part of the protocol, requiring no programming in the RTU to implement these functions. Taking advantage of these is another way to keep your hands off the keyboard and further optimize the efficiency of delivering a plant structure solution. Here is a basic comparison of the previously reviewed level transmitter DFB used for OFS OPC driver versus the one to be used with the DMPR driver. Is the internal logic the same? Check. Are the public variables the same? Check. Notice that the new DMPR version has no SCADA data object, and what are those new DFB pin variables doing there? No worries, the DFB manager has got your back again, just as before with the OFS OPC version. Again, boom, done. So let's take a look at the input pin variables. As with the OFS OPC version, EDT variables are required to enable these variables to be individually and uniquely identified as Vijeo DMPR variables with DMP3 point addresses. The DFB manager can auto-assign DMP3 point addresses into a target Unity Pro project. This furthers the optimization of the ease of use of these DFBs used in M340s with the DMPR driver. And as with the OFS OPC version, these output variables also have the U2V syntax and parameters assigned. Are we there yet, you ask? No, we're not there yet. But don't fret, details for the U2V syntax and parameters is coming. Well, I've covered quite a bit so far, but here comes the meat and potatoes. I will now deliver what goes into building an optimized U2V control object, specifically here, the DFB part, which I refer to as the control object. The operational object will be in part 3 of this series. To explain building an optimized control object, I will use one of the control objects presented in another of the YouTube video demonstrations. This control object is included in the U2V OFS OPC demo video. The field device is a motor-operated valve. Here are the requirements for the valve. It will have open and closed limit switches and also a locally mounted open-close auto selector switch. The SCADA requirements include visualization of the valve position, open, closed, and in travel, and a common alarm. There are alarms required for travel fault and the local switch not in auto. And lastly, we must be able to control the valve open and close from the SCADA system. Here are the PLC I/O requirements. 3 inputs and 2 outputs. All are discrete I/O channels. I will show 3 versions of a DFB created to meet these requirements. One for a native modbus driver, one for the OFS OPC driver, and another for the DMPR driver. First, in Unity, the OFS OPC version. This is the DFB project. Remember that a DFB project is created for each DFB, and it only contains the DFB definition and a section containing an instance of the DFB with all of the appropriate pin variables defined and attached to the instance. Note that the DFB project name is the same as the DFB name. This is required by the DFB manager. Here you see the U2V DFB template section with the attached variables, and below the Unity data editor showing the variable definitions. The variable names include the substitution marker _x and the variable comments and _y. Also shown is the U2V examples standardized object naming convention, which is based on the ISA 5.1 standard and includes the U2V suffixes to identify variable usage. The DFB manager will be used to substitute instance-specific strings in place of these markers. You should know that Unity Pro also provides a means to accomplish a find and replace when importing a section. This is done by checking the box Use Wizard during the import process. The difference is that the DFB manager can and does go much deeper into the replacements made. This includes assigning values to the DFB public variables and modifying section variables' custom field content. All of this is done to optimize the DFB for ease of use by minimizing keyboard usage. This is the OFS OPC version, so it is built specifically to be used in a plant structure solution with Vijeo Cytec. And in the custom field, you can see the U2V VJC builder syntax, identifying these variables for use in Vijeo Cytec and how they will be used. Here for review is the U2V VJC builder syntax, and it is shown with the U2V parameters. So are we there yet? Yes, we are there. Pause the video and review this, as I will not read it to you. But here's the tip. If you will be using the DFB manager, you can create public variables for a DFB that are of the string data type. Then use that variable name in the U2V VJC builder syntax. This will cause the DFB manager to prompt you for the instance-specific value to use for a new DFB instance and a DFB template section instance. Here in Unity is the implementation of the tip. I have set the default value of these DFB public variables equal to the name of the variable. This condition is trapped by the DFB manager and will cause the prompt for a new value. Here is another tip if you will be using the DFB manager. Public variables with no value. These will also trigger a prompt by the DFB manager for value assignment. For a demonstration of these tips in action, watch the U2V OFS OPC demo video. Okay, moving on. Here is the modbus version, the DFB template section, including the substitution markers in both the variable names and comments. Also note the addition of the SCADA data object, which consolidates all of the SCADA communicated data into an easily locatable variable for use with SCADA systems using native modbus drivers. Another tip, the U2V syntax can include the marker %MW as a suffix. The DFB manager will assign the address %MW1 to all variables that include this marker. Unity Pro will then throw a warning flag at the user on an analyze and/or build because of the memory address overlapping. This further reduces keyboard usage and aids in the required locating of retentive and/or modbus communicated data. And now the DMPR version. DFB template section again, with the substitution markers in both the variable names and comments. This time, however, there are new pin variables required, and to further the optimization for ease of use, the addition of the BMX NOR RTUConf syntax to the U2V VJC builder syntax. Let me break it down. Here are all three versions of the DFBs with their attached pin variables, and here is how the specified requirements for the motor operated valve are achieved by each. Breaking it down some more, SCADA visualization. The Modbus version uses 4x or %MW located words, which are bit packed with the discrete I/O channels. The SCADA developer will need to create variable tags for each of the used bits and address these to the native Modbus driver as required. Oh, and this means the SCADA developer's hands will be all over the keyboard. The OFS OPC version? OFS can access all data, and the Vijeo Cytec variable tags are auto-generated by the U2V VJC builder. The DMPR version. BMX NOR DMP3 binary inputs must be assigned to either %M, %MW, or unlocated variables. The BMX NOR does not allow direct I/O channel access, so the I/O state is simply moved from the I/O variables to unlocated variables. that are linked to the DMP3 points. Note, unlocated variables are used wherever possible for both OFS OPC and DMPR. This further optimizes ease of use by eliminating the need to assign addresses, and therefore typing. Breaking it down even more, the SCADA alarms. Again, the modbus version uses bit-packed words, and the SCADA developer has hands-on keyboard. The interface and communications for the OFS OPC and DMPR versions are the same as with the visualization requirements, with the U2V DFB Manager and the U2V VJC Builder tools minimizing the development work. Breaking down the SCADA control. More of the same. OFS OPC and DMPR versions comply with the U2V Golden Rule. Using the object shall require minimal keyboard input, or don't make me touch the keyboard unless it's absolutely necessary. The last breakdown, the PLC I/O assignments. For all three versions, the input and output variables will be assigned their hardware addresses by the U2V DFB Manager I/O assigner feature using drag and drop, which optimizes these DFBs for ease of use by eliminating the need to touch the keyboard. Okay. This is the last and final break it down, the DFB internal logic. Here is the OFS OPC version, and as I have stated, the logic inside of these three DFBs is exactly the same as related to the requirements of the control specification. However, there are slight differences when we take the SCADA communications protocol into account, and I will show these differences in this breakdown. Here is the DMPR version, and the only difference is the addition of the mapping of the hardware I/O channel variables to the DMP3 point variables. Here is the modbus version, with the differences highlighted. Let me zoom in on this. And again, the main difference is the addition of the mapping and bit packing of data into the SCADA data object, and a change of the source of the control for the motor-operated valve control outputs to bits from within the SCADA data object. And now, a final wrap it up. Unity Pro DFBs optimized for ease of use must require minimal use of the keyboard, take SCADA and protocol into consideration, be easy to find and update, have a help file, be maximized for efficiency of communications bandwidth, PLC memory usage, and impact on scan time, and require minimal use of the keyboard, and oh, did I say it? Don't make me touch the keyboard unless it's absolutely necessary. I hope that this was informative and provided a few tips and tricks that you will find useful. Don't forget that the Unity Pro companion tools are freely available for download and use by clicking on the icon on the Unity Pro Experts YouTube channel art banner, or on the About page. Thank you for your time and have a great day. Subscribe to this channel to see more demonstrations of Unity Pro tools, tips, and tricks.